Hello again, Tom from everystepcalculus.com, everystepphysics.com. This is a calculus problem regarding ellipses, and the problem in the test was find the area of the region bounded by ellipse, and this is the equation, standard ellipse equation. Okay. We just explain a couple things about ellipses. The largest number in the denominator, okay, if it's under the x value, it's a horizontal oriented ellipse. If the largest number in the denominator is under the y, it's a vertically oriented ellipse, okay? Generally the equation is 2x squared minus h plus y squared minus k. H and k is the center of the ellipse, okay? In this case, h squared or x squared plus 0 plus y squared plus 0, so both of them are 0, so therefore the center is 0, 0. Whatever's in the numerator, and you know, if it's x squared minus 6, for instance, whatever, then you change the sign, and the 6 would be the x value, 1, 2, 3, 4, 5, 6, etc. So keep that in mind, just as a general knowledge of ellipses. Okay, now we're going to do this problem here with my programs, and we're going to find it in the menu because we're dealing with ellipses. Okay. So here's the menu. We're going to go down here to the E section, scroll down, whatever you want to find. It's like an index of a calculus book. Even better because you can do all the calculations step by step. Now here's ellipse here. Choose that. We're going to use calculus to find the area of an ellipse or the volume of an ellipsoid. Ellipsoid is like an egg with the same radius, of course, but they have two radiuses possible on ellipsoids too. And then we can find the parameters and graph an ellipse too in these programs. So in this case we're going to find the area. We choose that. I'm going to enter the first term here, x squared over 16. The reason I do that is because if I put it all in here in one equation, the calculator will find the common denominator, etc., and screw up the system for finding ellipses. So I have to put each one of these in separate. So we're going to put the x value in for it. You press the alpha button first and then enter these. So it's alpha x, I'll push it here, alpha x squared divided by 16. I always show you what you've entered. You can change it if you want. I say it's okay. We're going to enter the second term with the y value, okay? And I've already entered it, so to save time with the video here, y squared over 9, here's y squared over 9, and then I show you the whole equation here. And that looks good to me, so you don't have to change anything. We can say OK. I show you the normal intelligent way of finding the area of an ellipse. Here it is. It's pi times a times b, which is the two radiuses. So here's pi times 4 times 3. Notice the square root of 16 is 4 and the square root of 9 is 3. So here we have 3, and that's times those things is 12 pi square units. So that's the intelligent way of finding the area of the ellipse. Now we're going to go through a whole page of calculations, so let calculus do its pathetic thing here on calculations. And here's the formula. Area equals 4 times the integral of y dx. And we have 0 for the lower limit and a, which is the square root of a squared over here, for the upper limit. Now, since calculus can only do this quadrant first, you have to multiply this by times 4 to get the total area of this ellipse. Okay? And here's the larger denominator. I do that for you in case you didn't know what, you know, the larger number under the x or larger number under the y. And since it's under the x, we have a horizontally oriented thing, and here's the one coordinate quadrant with the radius 3 and 4. And we're going to isolate the y squared first, which is 9 times 1 minus x squared over 16. They do a common denominator, and we have 16 over 16, which is the 1, and then minus x squared over 16. Okay? They're all setting this up so that you can do a special identity trig substitution. And I'll show you that as we get down here. We're going to factor out the 116, which is 9 over 16 times that. We're going to find y, so we have to square root the right of the equation. We do that, we square root it, and then we do the square root, simplify it, 3/4 times the square root of 16 minus x squared. 16 minus x squared is the simplest that can be for a square root. We're going to set up our integral, 4 times 0, and here's the a, which is 4, 3/4 times the square root of 16 minus x squared dx. Always constants come out of the integral, 4 times 3/4. And we multiply the constants, which turns out to be 3. And then here's that special integration rule in the back of your, or somewhere in your calculus book. Square root of a squared minus u squared equals 1/2 times a squared times sine, arc sine of u over a, etc. Here's times u times the square root of a squared minus u squared plus c. Pretty simple. You got to memorize that now if you're going to do this problem. We're going to apply our problem to this substitution here. We do that, multiply the constants, and you can just mark all this down in your paper exactly as you see it. You get an A in this problem, of course. And then we do it for the limits, you know, where x equals 4, which is the upper limit, and x equals 0, which is the lower limit. That equals 0. Upper minus lower, 12 pi minus 0. Answer is 12 pi square units. Pretty neat, huh? EveryStepCalculus.com. Don't forget about EveryStepPhysics.com either. You can buy my programs and pass certainly calculus or physics. Otherwise you have to study for hours and you don't even know how much you should study. I study this stuff a long time to get all these programmed in here and study ellipses. I have to become an expert at ellipses and know exactly how everything works. But you don't need to do that. I do it for you. So anyways, good luck in your classes. Subscribe to my site if you want. That's on the bottom of the, you can, on the bottom right of this video is you can click on that button and you can subscribe to my site, either physics or calculus, okay? Hey, good luck in your classes. Have a good one.